Alright, is this better? Let me know in the chat if you actually can hear me now. I have a feeling that... Okay. Thank you, Matt. That was very kind of you. Yeah, this thing has happened to me once before. That was really strange. Alright. Coolio. So, I take it you guys just started hearing my voice, which is kind of unfortunate. Because I've been yapping for half an hour or so. Yeah, this thing has happened with OBS previously. Don't know exactly what's going on. Basically what I do is, for the audio and video, I set like a setting to something it's not supposed to be, and then I set it back to what it's supposed to be, and then it somehow refreshes. Like for the desktop, for example, I just set it to like my other screen, and then I set it to the proper screen it's supposed to be. But okay, let's start again. Welcome everyone. It's been a while. Saw the mouse moving in what looked like a presentationary manner. Yeah, thank you. That was quite silly of me. It's annoying because it looks to me like everything is working. So I probably need to double check in the chat or something next time around. You didn't really miss like a whole lot though. I was basically telling you that I've been messing around with PhysX lately, as some of you would know if you've been hanging around the Discord. Traction Point uses PhysX 4, or it has used PhysX 4. The game engine has used a bunch of different PhysX engines, and it started with PhysX 3.4, I think. But we've had some issues with PhysX 4.1 specifically, and specifically with the mother vehicle. I recently realized that the discussions we had on Discord might have given you the wrong impression. I think I mentioned that the mother vehicle, especially with the crane, occasionally got a little unstable, and you might have gotten the impression that it would sort of fall over, but it wasn't really unstable in that sense. It was unstable in the sense that the game actually crashed. And of course we can't have that. So I have done a lot of work lately on figuring out various issues related to the vehicle model that we're using, as well as trying out different things related to new features found in PhysX 5 and so on. And basically what I did just before we realized that the video wasn't working was switching the project to use PhysX 5. And of course we can do that with quite simply putting a number 5 here after the plugin name. So basis PhysX DLL is the old one, the one that was upgraded from 3 to 4. I've kept that around because, of course, upgrading the PhysX engine version this close to actually releasing the demo can be considered kind of risky. So I'm going to keep that around. So I just created a new one. You can see them here in the Solution Explorer here on the right. So So we have the old one here, which is PhysX 4, still works, and then we have the new one here, which is PhysX 5. You can see it has basically all the same classes even here. Just there's like a 5 after each name, essentially. And that is because we're quite simply implementing the same interface that the game expects. Alright, and what I started doing was actually create like a physics stress test thing here, because there's one case specifically with PhysX 4 that has been kind of problematic. It has typically caused the game to crash in about, well, sometimes immediately, but within the first 10 minutes of doing this thing, let's just say. And so I want to basically set up a stress test here, which I can run overnight and essentially have the mother vehicle drive around the level automatically while having this problematic case be active, so I don't have to test it myself. Hopefully it will, you know, stay alive longer than 10 minutes. My very quick initial first tests are showing promise, but we'll see. Aroxus MT says, "Hey man, found you from your engine history video and I like your channel, but thank you very much. You use an ECS." Not really, no. There's a video on the channel where I actually use an ECS with basis, and specifically an ECS in the sense that the game object model is driven by and sort of managed by that ECS. I guess that's basically what you mean. That's typically what people mean when they say an ECS. So this game object model that I'm using was designed quite a long time ago. ECSs weren't really a big thing back then, and there's nothing preventing you from just like using this together with an ECS, and that is essentially what I do in that video. But this game doesn't currently manage its entities, its game objects, using an ECS, if that is what you're asking. No. But I could definitely imagine using an ECS for some sort of some local thing. I mean, you can use an ECS basically like you can use an STD vector, right? Sometimes the STD vector is a very good and indeed the correct way to store a list of objects somewhere for a very specific purpose, and sometimes an ECS is the correct way to store a list of objects or manage a list of objects somewhere. So you can just use ECSs on a much more granular basis if you want to. All right. So let's see what we have. What is this gripper doing here, by the way? Oh, it's part of the test vehicles. Yeah, I guess it can stay then. So, anyway, I created a new layer here to get back to what I was doing before this whole OBS business started. A new layer called Physics Stress Test. It has a mother vehicle. It has a garage door from the ruin. This is a kind of a problematic object physics-wise. Then we have a free camera setup, which just poses the free camera here, so we can do our initial messing around with this thing. And we have a function here called Physics Stress Test, which quite simply loads that layer. Right, so let's try this. Let's see if this works first of all. Abel Rashid says, "Yo, what's up? What's up? Getting back into streaming after the holidays, and seeing what PhysX 5 helps with, if anything, coming from PhysX 4.1. This is PhysX 5.5, by the way, if someone is curious. It's the most recent version as of right now. Right, so... Oh, okay. yeah, the free camera doesn't actually work because it needs to be triggered on the client. Oh boy. Well, let's ignore that and get this set up. So basically what we would need to do here is, you can use this as the avatar. We lift this up, something like this. We lift this up into the air, and like I said, this door, especially combined with this cable here, is just like a recipe for disaster a lot of the time. So what I want to do is basically pose it like this, and unfortunately I can't like easily script this right now. I have to do this part by hand. And now that it's hanging like this, now I want to basically have the mother vehicle just drive around the level, you know, in circles basically, and take some slightly tricky paths through the level, and then just do that, because that has historically been problematic for it. So let's see if we can make that happen. Oh, hey Wookie, Happy New Year. Are you using your own physics library or an off-the-shelf one? I am using PhysX 5 as of today, basically. That's basically what the stream is about. But yeah, no self-made stuff on the physics side. Right, okay. So, how do we make this guy now drive around endlessly? That's a good question. So we can basically react to a message, and if the message is like, you know, go, or that's not how we do it. We say if the message is go, then we can append an order to it, move to object, and we can basically tell it, okay, drive to this target with this speed, and yeah, deactivate driving AI. We don't really want to do that if we just want to, you know, keep doing it endlessly. But that's basically what I want to do, I think. So what object would we drive to? Well, if we start here, and we kind of think that, okay, we'd like to drive maybe around the refinery to sort of stress test. Maybe we'll want to sort of start here and then drive like here, so we go past the ruin and then somewhere here. So we just make some of these waypoints kind of along the way, right? That makes sense. And I think we actually don't want to necessarily make them waypoints in this case. We want to make them triggers. So trigger areas. Let's put a trigger here. Let's make it large enough. Make like a sphere, and we can make it 25. Like so. Actually, this thing should probably be sitting right on the nav mesh if we want to actually be able to drive to it. So trigger 1, okay? And then we'll make a similar one. We'll put it here. And a third one over here, probably. Actually, let's make it even more trickier for them on the vehicle this time around. Let's put the trigger area here. I specifically want to make this sort of tricky, so it will have to do like a reverse turn there. Then put one, probably over there. And I'm sure you can sort of guess how this is gonna work. When it enters, actually those are kind of too large. Let's make them like maybe 10. When the vehicle enters one of these guys, we'll quite simply tell it to go to, you know, the next one. Right? Alright. Trigger area is something that we can make, and we can put these guys under it. And that means that we should be able to just have one of these guys. Let's see, void on object entered. So if the object that entered is level objects, this would be physics stress test mother1, send a message to the object, go to next, right? Something like that. So whenever the mother vehicle enters one of these guys, it will realize that, oh, okay, I need to go to the next one now. And then it's up to it to decide, okay, what does that actually mean? But let's see, let's start with this. So go is the message that it will receive when the whole thing sort of starts. And the target is, skip that around because my auto completion is kind of crappy. So the target is going to be level objects, physics stress test, trigger area, trigger 1, AI driving speed is fast, want it to go as fast as possible, and we don't want to disable anything when we actually arrive at the place. Let's see if this works. Oh, I need to actually send a message, right? So helper scripts. So when the layer has loaded, when the physics stress test layer has loaded, we send a message, and the receiver would be level objects, physics stress test mother1, and the message is go. Right? Yep, that looks good. Let's try that. Yeah, the level exporting is kind of annoyingly slow these days, unfortunately. That has to do with the grass that gets re-exported every time. I should really sort of cache that somehow. But that is what is happening there. But I guess we can live with that. It's not really a problem. All right, so you can see now the thing actually started driving, and I just realized that we need to give it a little bit of we need to sort of separate the actual starting of the vehicle, right, from loading, because we want to hook up this thing to the crane. I mean, it's sitting just nicely there on the back of the vehicle, but yeah. And of course it doesn't really continue currently, but we can make that happen. No biggie. Right, so let's just make another physics stress test go. Let's call that physics stress test load, and then go. And go is the thing that actually makes the vehicle drive away. This is all throwaway code, by the way, as you can imagine, I'm sure. So we load it, then we have a little bit of time to actually hook up this crane assembly thing here. All right, so how do we now make it drive around endlessly? Let's see if I can remember AngelScript syntax here. We can make an array of game objects, and this would be called like triggers. And I think we can do something like this. Level objects, physics stress test, trigger 1, 2, 3, and 4. No, that's not how we do it. Why is that not how we do it? Then how we do it? That's how we do it, apparently. All right. So we have a list of these guys, and And so basically we have an index into this guy, which is like the you know, the current one, the current target. What was the message was go to next, which was sent to the mother when it arrives somewhere. So let's just, message is go to next. Then we will bump that index, right? So we will have, you know, int trigger index is, let's make it -1. So trigger index is trigger index plus 1 modulo 4. Alright, and then we take like this guy. And of course it's not called that, it's called trigger index. Does that make sense? I think it makes sense. Actually technically need this go one, right? And just take that away because it starts at -1, so it just goes to 0, and then that should be good. Okay, I think that should work. We can, just to make it obvious what is happening, we can have it print. So driving to, and then basically this get name, I think, is available on those guys. Yeah. Okay. So go to next, and then we need to change the helper script here to actually send that message instead. All right. Let's see what happens. So we start by simply loading that layer, and then we connect this to the crane. Needs to be kind of roughly in the middle. Let's maybe move it a bit closer to the middle, like so, and then lift it up. I think I'll want the cable there to be a little longer than that, but we'll see. I'm not sure I have to do, you know, specifically exactly this thing, but this is something that I've tried in the past. I was actually trying to do something fun gameplay wise, and then it just kept crashing. And that's kind of how I found out about this issue. Let's make it a little further back still. All right, something like this. So this is now the case that is problematic for this guy typically. So let's go. And now, unless I've made some silly mistake in my script, we should just be able to sit back and watch this guy drive around. So it slows down. All right. So, all right. We got the driving to trigger 1. We didn't get the next one, right? Now if we just send it go again, it goes to trigger number 2. do wonder why that isn't working, but we can at least make sure that this driving here is actually working out, and then I can figure out why it actually doesn't work. The first one, that is. Alright, number 3, let's go. What's happening? What's going on? Why don't you want to? Oh, there we go. Not sure what that was about. Now, of course, it's confused because we asked it to drive sort of straight to... Yeah, okay, now something's completely wrong. Well, that was... that was brave of you, but okay. Okay. Yeah, one thing might be actually that we have to clear the AI queue, like the scheduler. It has a list of things. You can see here the primary layer. It already has a move to. It has one move to which is active, which is what is happening now, and then it has another one which is waiting to start. Yeah, so you can see now it's switched to that. So that would be. Yeah, it took a slightly weirder route. I don't know what is going on now. What are you doing? No, come on. Performing reverse turn to face point. I don't think you are, though. Reverse turn failed to complete. Alright, well we're finding bugs here, clearly. I wonder if it's something with this guy, like, is it the, is it actually... It's actually probably having an issue with this. Right? Yeah. I bet that's actually what's going on. It goes like, oh no, I'm hitting something that's behind me. Nav mesh is what I want. So this is the nav mesh that the mother vehicle uses. Now that's stupid if that's the case. Let's see if we can actually take the cargo crane here and just like lift this guy up. Lift it up. Maybe that's not actually the issue. Can see the wheel clipping you mentioned before. Yeah, we can take a small pause with this and look at some of the physics stuff that I did. So so this is the documentation for PhysX 5. Can I please close that? Thank you. So PhysX 5 has a completely new vehicle SDK. Yeah, significantly reworked in 5.1. And it is in many ways better than the old one, but it is very different. And I've tried out both now. So far, only for the four-wheeled vehicles. But I have here like a 4-wheel PhysX 5 vehicle 2 version, which is sitting behind a define currently. And then we have the old SDK, which is marked as deprecated in PhysX 5, but it's still there and you can use it, which we currently use. And the wheel clipping that Matt is referring to is the fact that by default the vehicle SDK uses raycasts for the wheels. And so let's see if we can, yeah, we can actually just play this from here, and it should go into a level that I set up for this very case. So here we have these obstacles, and you can see the wheel sort of clipping through that obstacle until it reaches the halfway point, at which point the raycast hits the obstacle and it kind of snaps so that it actually goes on top of that obstacle there, right? You can do sweeps instead of raycasts. You can do it with both the new and the old SDK. In the old SDK, the sweeping seems to be very, very broken. I'm not gonna say it's definitely broken, but I'm having really, really big issues with it. And other people on the GitHub for PhysX seem to have really, really big issues with it. To the point where I consider it almost unusable. It can be turned on, but I need to actually modify the shape of the chassis collisions. And so that kind of sounds like a filtering issue, but no, the filtering is actually completely fine. It kind of looks to me like they have to do so many hacks to actually get those sweeps started correctly that it just like it interferes with so many different things, which is annoying because it would be nice to get those sweeps working. In the new SDK, they actually work pretty well. And so what we can do here, just as a small little fun thing, is actually enable this new vehicle SDK. This should actually build pretty quickly because we're only building the plugin. What am I doing here? Okay. Yeah, I don't have those yet. Using the new vehicle SDK. Let's see if I just comment those out. Oh, yeah, I'm missing some if devs here. Let's fix this. So the old ones should all be sitting inside of an if not def sort of deal. We actually have an optimize off, which I can take away as well. Something like that, right? Same thing goes for the CPP side. I'm just gonna copy paste these from here. It's just quicker. Like that, and then one for the no drive one as well. And that should be good. One there. And one here. Yeah, I just forgot to do this this morning when I ported these guys over to PhysX 5. Alright. this particular demonstration. Alright, yeah. These need to go inside of the if defs there. Alright, is that it? Not all code paths return a value. Yeah, these need to return like null pointers. You can see here that I have some of these controllers that I haven't actually even attempted to convert to the new vehicle SDK. But we have this 4-wheel. So this says 4-wheel PhysX 5 vehicle 2 controller. So this is using the new controller, and the good news is that the sweeping works quite well. Oh yeah, I think I had some spring forces here. Oh, sorry, I'm hitting my microphone. I had some spring forces here that for some reason got halved. So let's just spring strength, just double that. And that should give us roughly what we need. Now this vehicle controller is like super work in progress. It doesn't, for example, you can see it doesn't emit any particles or anything like that, and also there's no engine sound or anything like that. And this HUD doesn't react because it doesn't report it, like the proper values to the game. But what you can see now is that we are doing proper sweeps. So you can do things like this, and it kind of behaves exactly how you would expect. Oh, and I also can't reverse because I have no gearbox in this guy. No. Let's create another one. Move to this. But this is very nice in the sense you can clearly see that this is with a little bit more work, or probably actually like quite a bit more work. This can be kind of nice because now it kind of handles these situations with the geometry underneath it kind of well, rather than just snapping. And so that's really nice, but it's not something that I'm gonna do. Well, at least not for the demo. Not necessarily for traction point at all, because there's just so many things that need to be tweaked properly and nicely that it's a little bit of a risk to switch vehicle models at this point. And in theory, you can do the same with the old vehicle SDK, but it just completely seems broken to me. So unless I make some pretty significant changes to the geometry of the actual vehicle, I don't have it working at all. And even if I do, the sweeps just break down completely when you throw like a bunch of dynamic objects onto the car and things like that. We don't have that problem with this new vehicle model, but yeah, this is completely different code. So this is kind of the story with this. Another thing that is a little not necessarily worrying, but something that needs to be taken into account, is that this changes the feel of vehicles like the Scout quite considerably. Oh, I'm almost falling off the level there. So if you're driving very fast, the feeling is very much not the same as it used to be. Like that, for example, the old vehicle would have handled that just fine. Like you can drive very, very fast and smooth over sort of imperfections in the ground with the old model that this new one just doesn't do it. And I mean, neither should it, because it's more realistic. If you're driving the real car onto like a curb that's this high, then you're gonna run into issues. So it may be that the best course of action would actually be to have sort of like a mixed model where the fast vehicles would use the old vehicle SDK, or not necessarily the old vehicle SDK, because you can do raycasts with the new one as well. But anyway, small and fast vehicles would use raycasts, and larger ones would use sweeps. I don't know. We'll see. See what happens. But yeah, that's sort of like the story with this thing, and I would like to actually spend quite a bit of time on this new model. It's pretty nice. So this is code that is taken just directly from the snippets. You can see snippet vehicle 2. This is part of PhysX SDK. The way this new system works is that you have a vehicle which I eventually would derive from this engine drive vehicle. This is the one that models the whole engine and gearbox and clutch and differential and all of that. Currently what I have is this direct drive vehicle, which is like super simple. You want to go forward, you just like, you know, increase a float value, and then the wheels start turning. And then this guy derives from PhysX actor vehicle, which kind of handles the whole integration with the rest of the physics world. Like technically you don't even need to have like a rigid body in this new model. But if you want it to collide with other dynamic objects and all of that, then you will probably want to derive from a PhysX actor vehicle, and then all of them derive from this base vehicle, which just sets up things like, you know, suspensions and tires and wheels and all of that. Yeah, don't be fooled by this guy. It's just there to actually give some very specific features to the car. Let's see, forward integrated momentum. Yeah, kind of sounds like it would handle rigid bodies, but actually doesn't. Or it handles rigid bodies, but not like PhysX rigid bodies. Handles specifically PhysX vehicle rigid bodies that are sort of like a separate thing. So this is pretty nice, because what you can do now is, if we go to the direct drive vehicle, for example, this guy has, I need to go to the CPP side probably. Yeah, so here's the component sequence. And this is essentially like the sequence of components that will get updated in this order defined by the sequence every time the vehicle is updated. And so you can just, you know, take out one of these components and replace it with your own, and just like add your own stuff here, which makes this new model very flexible, whereas the old one was just basically like black boxes, or much more sort of black box like than the new vehicle. So this should allow us to do all kinds of really interesting things with like really complicated vehicles in the future. Oh, and it also allows you to have things like these subgroups here, where like at low velocities, for example, certain things just get like more tricky to figure out. This is used for stability at low forward speeds, yeah. So you can just like, you can tick certain parts of the update, you know, for example here, just 3 times. And then other parts that are more expensive, you just tick once. Things like that. So it's pretty cool. I like it a lot. I just wish it wasn't such a big part to actually move everything over to this new model. But maybe someday. maybe for some vehicle we'll actually do that. But okay, that was good. I fixed some compilation errors in the process. Actually, let's see one more thing here. Needed to comment those out. Like, why would this compile but not these two? That's strange. Yeah, it's because of that, right? Okay, yeah. Yeah, I'm gonna have to slap like an if not def on these for the time being. And then this should actually build. Yeah, I can actually just move that. Like so. Alright, so now this builds. That's good. And now I should be able to toggle back the define, switch it to off, and it should still build. Uninitialized local variable. That's probably fine, but let's maybe do it like that. There we go. Alrighty then. Let's have a quick look at what is going on with these triggers here to see if we can get this mother vehicle to drive around its circuit. And I think also we will probably want to... Oh, did it actually crash? Ah. What? Kind of looks like the game crashed. That's not good. What's going on? Let's make sure we can actually run this. Yep, that looks good. Okay. Yeah, something's happening. Okay. Let's see. I'm probably doing something strange now with the physics here. I bet. So the way we can debug this now is by toggling a wait for debugger checkbox here, and that makes the game wait like this with a message box, so you have time to actually attach a debugger to it. And then when it is attached, you just click OK. And now we should be able to see what's going on. So it's loading the resources. Ah, yeah, it was probably just rendering these thumbnails. Aha. Okay. Oh, right. Right. I needed to do this in two places. And I fixed them in one, but not the other. Okay. Okay. That's not good. So it needs to be like this, of course. Like that. And then again, we can bring this into the same if def as the one below it. That should fix it. Yeah, that makes sense. I mean, it worked previously, and then I fixed that. Fixed in air quotes. And then it broke. Okay, good. All right, that's better. Okay, I think I mentioned here previously, but you may not have heard because we had the OBS issues. We have a new solver in the PhysX 5 version. And so if we go here to constraint solver, we have a projected Gauss-Seidel and a temporal Gauss-Seidel solver in PhysX. The projected one is the old one, and the temporal one is the new one. And certain things, especially with the mother vehicle, since it is built up of essentially like a tree of rigid bodies with joints between them. Certain things have always been kind of problematic with the mother vehicle if it has things like the crane installed on the back, because you can run the mother vehicle just without the crane if you want to. But if you have the crane component there, teleporting the mother vehicle, for example, has typically led to a crash with PhysX 4. And my theory with the crashes that we've had previously is the fact that since we're using raycast wheels, the velocity of some of those corrections are high enough to essentially trigger the same issues as with teleporting. So the actual issue is that we get infinite values in the linear and angular velocity. Now this new temporal Gauss-Seidel solver actually handles those teleportation cases just fine without crashing. It's not necessarily all that pretty, because you still have a tree of rigid bodies, and you essentially teleport the root, and the joints kind of try to fix themselves up over time, which results in some jankiness there. but actually teleporting a large object like that probably needs to have some special code anyway to handle things like the chain or the cable from the crane. But I'm quite hopeful that the temporal Gauss Seidel solver will handle cases where those raycast wheels cause sort of small jerks, small but very sort of fast jerks happening, and that is what I'm trying to test here and verify with this stress test of ours. So let's move this trigger like way closer to the mother vehicle so that we can almost immediately hit it. Put it somewhere there maybe. I mean, that gripper is not going to be there unless we load the layer that it's sitting on, so it's not going to be an issue. How did this trigger area actually work? I'm probably not remembering this correctly. Yeah, okay. So it's not as it's not as automatic as I remembered. You have to kind of manually do some bookkeeping here. So the way this works is that these triggers, they send messages to their parent. And the idea with using a trigger area like this is that you can just send like you can have the same script on all the triggers. Like this. So that was maybe not that handy, but you can consider, for example, copy pasting one of these and then just adding an area with lots and lots of triggers. They send an enter and exit message to their parent, and the parent then keeps track of like, okay, what object is that, and then it can fire this on object entered thing. So I think that was probably the problem that we were having, that we weren't sending and receiving these enter and exit messages. Let's try that out, see what happens. So the trigger area is really just like a small helper type to allow you to create. Oh, did I cancel it? Yes, I did. A small helper type to help you create or allow you to create like areas of any given shape, essentially, because it's sort of like a compound trigger. Alright, so let's load the layer, and then we can even probably see the shape here. It's on the server, right? Yeah, so it's over there. And now if we tell it to go, there we go. So now it's doing its thing. It's striving to trigger 2, etc. So that's nice. Okay, we don't want to trigger there though. We want to move it back, because then of course it's gonna do its circuit, and we don't want it to drive out here anymore necessarily. So let's move it back here, put it right above the ground there, and then I think maybe we'll move that a bit further there, something like that. So that should work. So now we should be able to hopefully see this in action. There's still something strange there with that reverse turn. I haven't really seen the mother vehicle have any issues with reverse turns ever, basically. But we'll see. We'll see how it does. I think we won't actually configure the crane now. Currently, I'm gonna want to actually just I'm gonna want to see it just drive. Oh, yeah, I made it the avatar, which means that it loses its AI, but we can probably tell it to drive directly to trigger 2. Yeah, so if you want it to, like, I'm not driving it now. Now the AI is driving, but if you want the camera to be attached, you'll want to set the avatar first and then trigger the script, not the other way around, because when you set the vehicle as the avatar, it kind of disables the AI for it. Right. Oh, 1, 2, 3, 4. Yeah, I wonder why is it doing. Why is it doing 1, 2, 3, 4? Is it something with my script here that's stupid? Yeah, let's try that once more without actually messing with it there in the beginning. Maybe we'll put in some more debug texts here. So we entered trigger 1, 2, 3, and 4. Yeah. Yeah, let's add like self print info, sending go to next, like that. Yeah, that should be fine. And then we're going to want to enable the brain debugger immediately to see what it actually is planning to do. So I'm pretty sure this has nothing to do with physics actually, but if we have a bug in our driving, which I admittedly haven't really seen, but if we do, then I want to fix it. So, go. I'm just gonna keep the free camera active for now. Yeah, looks good. Right, it doesn't want to go there. It wants to. Yeah. Why do you not actually? Did we actually just quite simply manage to find like a place here where we reach some sort of edge case? Thinking we probably have. Oh, that's stupid. Okay, well this this needs to be looked at for sure. But in the meantime, let's quite simply not care about it. I'm gonna add another trigger there. And then maybe move this guy over there. Right, and then now we can copy paste this. And it comes copy pasted with the script and everything, so we don't need to script that, but we do need to make the actual vehicle aware of this trigger, of course. So quite simply do that and then modulo it by 5 instead. Yeah. Something like that. And the reason it didn't want to go the sort of straightest way to the next one is that it wants to drive along the roads as much as possible. So load and go. Alright, sorry about that. I have to take care of some real life business here. For some reason, this guy really doesn't want to do anything. Isn't that peculiar? So it says that it's driving to trigger 4. Ah, look at that. It's just me being bad. Yeah, it was driving to trigger 4, and then it was driving to trigger 4. So it had arrived, basically. Okay, well that's on me. That is on me. So let's try to remember to set the avatar here so that I don't have to mess around with the camera at all. Alright, so now then, go. And so basically it should make a reverse turn when it reaches the, what is it now, 4th point? And it kind of looks like it has had some issues doing those. I'm not exactly sure what that's about. There is of course a possibility that PhysX 5 somehow affects that. I haven't seen anything like that with you know, just driving around and asking this guy to follow you or whatever. But it's possible that PhysX 5 causes something like that to happen. So we'll have to see. But okay, again, I'm not driving here. It's the AI driving, and basically, I just want to make sure that this thing can drive in circles forever and ever, because then I can just leave it on later. Make sure that this works. And what is nice here, originally I was thinking like, oh no, it's like again it's taking some wrong turns here, but it's actually completely correct that it goes down there, because it doesn't actually fit under the monorail there. So even though that would be the fastest way for the Scout, the mother vehicle doesn't want to go there. Or it can't go there. It could probably drive under this one here, but there's a road here, so it prefers the roads. And then maybe it could drive up there, but again it prefers the roads, so it's gonna take this road here. And then let's see what happens when it comes to the place. We can turn on the physics shapes. Alright, so now it's driving to trigger area 5. Interesting. It's going this way, but that was probably actually a pretty good thing to do. If it can manage this turn. Nah, I don't think so. Yeah, see, this is an issue. It doesn't seem to want to do. Doesn't seem to be able to do the. Yeah, it detects that the reverse turn has failed. So it looks like it can't engage its reverse gear. That might actually have something to do with PhysX, yeah. Yeah, so there's probably something wrong there. Something broken. Interesting. Okay, let's try something else here, something simpler. if we just run the game, we can run it up. We can run it from here. Just to finally block out. Actually, I need to run it through the campaign if I want to be able to issue orders to it. Yeah. Okay, well, I'm gonna have to load the game here. So, basically, what I wanna test here is if I just ask it, hey, come to me, you know, by standing behind it and asking it, hey, come to me, it should basically make a reverse turn and then write to you. And we can test that with PhysX 4 and with PhysX 5. Then just see if there's something strange going on with the PhysX 5 backend. All right, and let's turn on the. Can I turn on the debugger? No, we're not running it on the same thread. Okay, that's fine. Okay, come here. All right, so it is actually doing it now. So it's not. It doesn't seem to be like a physics issue. There's something strange with. There's something strange with it in that very specific case, where it can't actually manage to do any reversing. Hey, Lucky Hits. What's going on? And yeah, I saw you in the chat there previously, but turned out I had some OBS issues, so you guys weren't able to see or hear me. Yeah, so this doesn't seem to be an issue here. We can actually even maybe make it more explicit by toggling this server thread flag here and running with that. What are your thoughts on Odin? Since SIG is not fully released and Odin is a more game development focused. I haven't written a single line of Odin. First of all, let's make that clear. I'm not. I don't think there's necessarily anything better or worse with SIG or Odin when it comes to game development as of right now. But you are absolutely correct in the sense that SIG is not released yet. Let's make that a little lower. Alright, so now we should be able to enable this debugger here. Here we go. Alright, so performing reverse turn to face point. And then reverse turn complete. Yeah, reverse turn complete. We never got that previously. And then predicted a hazard. And then it does another reverse turn. Yeah, for some reason that never happened. I'm gonna have to look at what that is about, but it doesn't seem to be physics related. So that's good, because that means that there is a bug, and we have to find it. But yeah, I mean, Odin is probably a pretty good language for games. I actually kind of joked with Ginger Bill the other day on Discord that I would write the next game in Odin. So we'll see. I tend to make kind of object-oriented-ish APIs. And I know that Odin doesn't have methods, so it would be sort of a probably even like a good sort of language in the sense that it would force me to think about API design a little differently. Ginger build is a huge plus for Odin, yeah. Yeah, it seems very nice. It seems like a very nice guy. Yeah, someone asked me on Discord, like, why did I go with you know, this hybrid model of C++ and Zig? And I told them that, okay, well, I like Zig, right? But I had this engine going and have had for a long time. And I wanted to use it because I have the whole editor and all the tools and everything set up. So I want to use those. But I want to write the gameplay code in Zig. And that's why I have this hybrid thing. And then I said something like, if I was to start today, I might write the whole thing in Zig or maybe Odin or something like that, right? and then Ginger Bill entered the discussion and said something jokingly about that sounded like a very good idea to write it in Odin. And I told him that, yeah, maybe next game, but let's try to ship this first before switching languages again. But yeah, I'm not seriously, I'm not considering ditching Zig at all. I like Zig quite a lot, unless they make some really big departures from what they are currently doing. Then I think Zig is probably a language that I'm going to use even after this project. But yeah, Odin seems kind of nice. Okay, so we have another thing to debug here in just a second. So what I'm going to do is I'm gonna go make myself a cup of coffee, and when I come back, we are going to look at why this guy doesn't want to make a reverse turn when we... Oh, hey, let's try one more thing before I go. Let's try one more thing. Because we're not actually doing, you know, we're not doing things the same way that we did. We actually had a garage door on top of the thing. If it has a garage door on top of it, does it still know how to make a reverse turn? That's what I want to know. Alright, come here. Yeah, doesn't seem to be any problem. I mean, I wasn't expecting it to be, but you never know with these things. Yeah, like the whiskers are down here, so even if we have that garage door sort of hanging off the back, it shouldn't really be blocking. Oh, good morning, Aku. It always seems to be morning where you are. I like I like it. Either like actual morning or then just morning as a state of mind. But nevertheless, I enjoy it. Alright, yeah, so quick coffee break, and then we're gonna figure out why this guy doesn't want to do reverse turns. It's a little bit of a detour. It's not exactly what I wanted to do, but it's required to get our physics stress testing going. So we're just gonna have to do it. Right, so let's put up one of my beautiful graphics here. Let's see, lunch break, no, quick break. quick bake looks like a good thing, and I will be back in about 10 minutes or so. Alright, hello, hello. I'm back. What did I miss? One thing about Ginger Build annoys me. In every place somebody mentions making games in languages other than C++, I see Ginger Build advertising Odin, saying you should make it in Odin. That's interesting, because did you guys see what's his name? The Primogen. Another interesting internet personality who he had a discussion with Casey Nakamura or Nakamura, or however you're supposed to say it. And they were talking about programming languages, and one thing that came up was that Ginger Bill's approach to marketing Odin is good, because he downplays it. He's like, yeah, you can use Odin if you want to, but it has this issue and it has that issue, and you probably shouldn't choose it. Yeah, the mustache guy. Mustache guy indeed. Yeah, he's a little hyper for my taste, but he does seem like a genuinely pretty down-to-earth, pragmatic programmer sort of guy. Based, as the cool kids say these days. He seems like a... Oh, Casey Muratori, yeah, not Nakamura. Where did I get Nakamura? Probably from Mitchell. Is it? What is the name of this person? Trying to see here. Yeah, I don't know. Oh yeah, Casey Muratori is who I was thinking about. Getting my my names wrong here. I always thought that Muratori was somehow Japanese, but apparently it's like Italian. I don't know, like Nakamura is Japanese. I thought he was of Japanese descent, but apparently Italian. So I keep messing those up. But yes, they were talking. I don't remember who was of the opinion that Ginger Bill might be downselling Odin, perhaps even a little. And the sort of gist of it was that that's a good thing, because everyone gets to make up their own mind. And just to be perfectly clear here, I was the one who actually brought up Odin in that Discord discussion where he jumped in, so he was perfectly welcome there. It's fun to see people appearing and advertising their things if it is sort of like a suitable context. Casey is American, yes he is, but he is of Italian, like Muratori is Italian, so I guess, I don't know, some Italian American family these days, I guess. His biggest lose is that he's a British. I don't know. Is that really a downside? Being British? Don't necessarily think so. Okay. How do we actually test this out now? Let's make a small change here. See if I can reproduce this issue that we were having, just straight out without any other messing around. Actually, we can probably turn this guy around like this, and then the spawn point. That's the spawn point, right? Yeah. Hi, William. Welcome. Yeah, so if we spawn behind this guy and we just quite simply ask it to come to us, then wouldn't that be good? Am I missing some sort of like initialization or something on this guy? What's it called? On create. Probably not. I think I had something that you needed to call previously to sort of engage all the AI systems, but I think I took those out, so that should be fine. Let's just create just a straight up callable function here. Come to me or whatever, right? And yeah, we can set this single player avatar, but we can't actually get it. But what we can do is just take, like, for example, the first trigger here, and then just go self, append move to object, that one, AI driving speed fast and false, and then see if that actually works. So if we load this, like, we don't have any come to me here yet, but if we load this, we should now have come to me. So please come to me. Yeah, look at that. Now they do a reverse turn quite happily. So what's with getting stuck there then? What's that about? Oh, oh that was a bad place to start making reverse turns, you know. Yeah. Okay, so it does work. Okay, that's interesting. Even avoids driving onto us. Well, just a little bit. So all that works just fine. Okay. How strange. Yeah, we can actually. Can we? No, we can't actually kick off the thing there, right? Can we? I'm not sure. But okay, so that didn't reproduce the issue. So what I'm gonna do then is, quite simply, we are going to debug the AI. And we have the driving. We have the AI driving component here. And this should have a, what is it called? It's called something like reverse turn logic. That's what I want. And reverse turn logic should, let's see. Yeah, the first thing that we could actually test is just to see what gear it is actually in. I think we should be able to see that already. Let's have a look. Extraction point fully zig. Well, probably not what you consider fully zig, no. The engine is C++. And in fact the exe is actually C++ as well. The zig code is loaded in as a library, a DLL. The thing with zig though is that almost nothing is fully zig, right? in a sense, no one really makes a game fully in zig. If you think about it, almost everyone uses something like SDL or Raylib or, you know, another one of these GameDev oriented libraries, and they all tend to be C or C++ or something like that. So almost nothing is fully zig. In my case, my engine, it doesn't actually use SDL or Raylib or anything like that, but it is what I use to, you know, interface with GPUs and physics libraries and sound engines and everything. And it is written in C++. Does that make traction point fully zig? Probably not. Not really what you would consider fully zig, I guess. Where, you know, the exe is actually compiled from zig. So that's it. But for example, this code that we are now hoping to debug here is going to be zig, because the whole AI system is in zig. Why don't I seem Do I actually not have the current gear showing there in the debugger? That's confusing. Oh, reverse mode enabled is actually there. Yeah. Reverse mode enabled is... That's not really the current gear. That's like the AI thinking that, oh, it should be in reverse mode now. So now it's gonna drive into that cliff, and then I'm hoping that it will... Oh, look at that! Now it's doing the reverse turn. So what was the thing earlier? Why did it not actually? I mean, that wasn't very elegant. It kind of drove head on into the cliff. It shouldn't do that. But if we kind of don't consider that for the time being, what was the thing previously when it didn't know how to make a reverse turn? That was strange. Oh. Yeah. Not wrapper. Zig can use C code bases directly, so you can invoke SDL functions directly with Zig, for example. Yeah. Yeah, sort of. Don't know if you knew, by the way, but Zig actually, when you import a C header, it actually generates Zig code from that header. As far as I know, that is how it actually then uses that header. You can find it if you go digging into your Zig cache, which is a folder that gets created when you build. You can find your imported C headers there, and the symbols and constants and everything. So whether or not that is like, you know, I'd say it's technically correct to say that Zig uses C directly, but it actually kind of converts it to Zig, as far as I know, at least. But yes, it can link to a C library, for example, just like a C program can. So in that sense, it uses it directly, I would say. And yeah, if you want to use like errors and all of that, then there are wrappers for that. Way. Let's make sure I don't actually talk out of my ass here. I don't use a whole lot of C headers in Zig, but I do use one. So if we go to let's see, where is it? It's in messaging, isn't it? It's engine messages. Nope. Yeah, here we go. Yeah, it is actually this thing. Right, so here you can see this comes from oh, it's actually in the temp folder now. Maybe this has changed, or maybe, you know, maybe it was never in the Zig cache. I don't remember exactly. Well, it might also have changed. But here we have, for example, my my message categories. These are defined by me. If we go have a look at, just search for that one, for example, and we go find it here, it should be in engine messages. Is it? Yeah, it's like that. Right, so here you can see. Make that a bit larger for you. Here's an enum and the enum has some constants, and then they get turned into public constants like this of type U32, and we have a bunch of messages under it, like, you know, layer created, for example. We should be able to find that as well. Yeah, it's right there. So, but yeah, it is done for you. This wasn't, just to be clear here, I wasn't trying to disprove any of you. This was just more of like a, did you know that is what is happening. And that one header is also the only header that I include in my SIG code. All the other stuff is handled separately. And I probably really should at some point try using something like, you know, Raylib or something with SIG directly and see how that works. It's probably actually really nice. I'm expecting it to be really nice. Okay, we have the mother vehicle now driving around this circuit without getting stuck too much. So that's good, I guess. I'm a little disappointed in the way it handles this turn here. Shouldn't be this bad. Evidently, I haven't really. I mean, it kind of looks like it's it looks like it's being more sort of intelligent than it really is. Starts by making a turn to the left, and then at some point it has more points to the right than on the left side. So it decides that it actually wants to go left instead. And then here, for some reason, those things don't. Yeah, it doesn't detect that hazard, as it's called. Let's see. Where's my nav mesh drawing? There's my nav mesh drawing. Yeah, so it should have detected those. Not sure why that didn't occur. It's a little violent, the turn it makes there. I don't like that. But other than that, it kind of works. So let's do this one more time, and I'm gonna set up the crane in its problematic configuration. The thing we actually wanted to try originally. So we load the layer, boom, and now then. Let's lift this up. I'm gonna go work. See ya. Well, thank you for stopping by. See you later, maybe. All right. The issue here is that we have this configuration now here with the main rigid body, which is the actual vehicle. You can see here that some of these things aren't actually, they don't even really exist in their PhysX form on the client. For example, this cable and the magnet, they don't actually exist physics-wise on the client at all. They only exist on the server, like this. So we have the main rigid body, which is the car. We have another rigid body, which is this what do you call this? I call it a bone in the code, but it's sort of like this first piece here of the crane, and then the second one is up here. If you're wondering why it's flickering, by the way, I have a special rendering mode enabled in PhysX, which draws like the state in different colors. Some of these things are like they're somehow almost falling asleep, as far as I know. That's why it's sort of flashing. And then now that fell asleep by some. It's not really asleep, but it signifies some sort of activation mode. Those colors. And yeah, it also shows the center of mass frame, which this is actually not a collision, it's just the center of mass is kind of visualized using this larger sort of frame here. It's the same thing with this weird tilted frame here around the car. Same thing goes with this. Yeah, red is actually falling asleep, so now if we drive this, it should change color. Yeah, now it goes to the weird flashing thing again, and then it falls asleep if we let it. But anyway, this is now the problem that we've had previously, is that this configuration gets unstable if the vehicle is nudged sort of violently enough. So let's see what happens. I should just be able to press go. And off we go. I don't think he means using railing for traction point. I don't know why I would do that. I was just thinking more like doing something, some small fun little test. I don't really have a need to use railing for anything with bases. Just if I did something without, and just try to go pure zig, essentially. Pure zig with some C libraries. This tends to be a pretty popular way of doing it. This turned out to be a pretty interesting test for a variety of reasons. A lot of the issues we've had here have actually nothing to do with physics at all. So I have, of course, played this level and the sort of scenarios that you have in the demo quite a few times, and the driving AI has worked quite well. But now that you do something slightly more strange, it occasionally breaks, and so it's a pretty good sort of test case for that. Even though we don't necessarily need it for the demo, we still want to make sure that it actually works. So, pretty good, pretty good. All right. Let's see now what happens when it does the violent turn there. If that garage door configuration is how it is handling it. I'm actually gonna open the debugger instead. Let's quickly pause this. Oh, now it went that way. Okay, well that was a better thing to do. That was a better solution than what it did previously, for sure. Yeah. All right. can see it being slightly careful with its driving, which is something that's, you know, typically a pretty good thing. In this case, I would actually like to have like a driving profile which is like, you know, don't care, just like full speed ahead. And not let off the gas at all, basically. I don't have that, unfortunately, but that could be kind of interesting. You can see the current speed here is about 50 kilometers per hour. It's actually capped out at 55, I think, that vehicle. So it doesn't go much faster. You can probably go perhaps up to 16 in like a downward slope. But it's being pretty careful here with its driving and braking and all of that. Anyway, if this fixes the issues, the crashes that we've been having, then that fixes some of the problems that we had on the physics side, but not all of them. Namely, we still have the jankiness that comes from the fact that we are raycasting the wheels. And so what would the solution to that be then? It's a good question. I have some thoughts on what I could do without doing full sweeps, because again, I don't think I want to change the vehicle model this late in the game's production if I can help it. What I would like to prevent is for the mother vehicle to drive onto a reasonably high cliff or some sort of edge, and then sort of jerk up along that edge to the top of whatever the obstacle is. I think that is kind of like the minimum that we need to prevent. For the Scout, I actually kind of like this model that we have going here. It allows you to drive very fast and carelessly around these levels. If you have a rock here, let's see if we can drive just over a rock like this. It generally just like handles them really well even if you have quite a bit of speed, which of course is not very realistic, but it's fun. It feels sort of physical enough, I would say, without being, you know, an issue. Mess with this guy a little bit. So you can just like, you know, you can just drive off rocks like that and you might flip, but still. I like this model, especially for the smaller vehicles a lot. So I don't wanna break it. Sometimes it jerks up a little bit, but that's fine. This for the smaller vehicles, that's fine. It's not necessarily fine for the big ones. The mother vehicle in particular. You're gonna want to avoid that. And so I have some ideas of how that might work while keeping this model. Another way to handle it would be to, like I said, just change the vehicle model for the mother vehicle, but not the smaller vehicles. Could even make like a very specific one for the mother vehicle using sweeps and the new system. That might be alright. Might be one way to handle it. Not exactly sure what the best course of action would be. Things like that. You don't want like the mother vehicle to be able to do things like like this, you know, if you consider it in the scale of the mother vehicle, which would mean suddenly jerking up like 2-3 meters. If there's some dynamic objects on the roof or the back of the mother vehicle, those just get shot into space. That's the sort of thing they want to try to avoid. Would you recommend using a PhysX / some sort of collision library, even if you don't need proper rigid body physics or other fancy features? Maybe. It all depends on the game, of course, or the app, or the whatever you're building. If that was the case, I wouldn't go with something as heavyweight as PhysX. I would probably use something like Bullet. Bullet is much more of like a collection of C++ classes that go well together. You can sort of just choose which ones you want to use, as opposed to like a full framework sort of thing like PhysX, which is like, okay, then now we are initializing the thing and now we need to provide it with, you know, a job system and memory allocators and everything, and then it kind of lives inside of your program and does things. You can override allocators and things like that for Bullet, yes, but you can also just like include some or all of the code in your own project, and then you can create like a broad face, for example, and then you can start putting things into the broad face, and then you can issue like raycasts or other kinds of queries or overlap tests or whatever you want. That might be one thing, I guess. You don't necessarily need to like do any stepping of physics simulations there to be able to use the collision detections. You don't actually technically need to do that with physics either, but it's like feels like a heavier sort of thing. And nowadays, of course, everyone is talking about Jolt. Not sure how Jolt handles that sort of thing. Does it give you the ability to just take like the collision detection, for example, and skip the actual dynamics? I think it's like everything else. There are a lot of great libs out there, but if you want to write one, then give it a go. Well, of course, yes. If you want to write one, then of course write one. I was kind of under the impression that Aku maybe doesn't want to write one. Excuse me. I have been toying with the idea of writing, since my physics engines are loaded as plugins. There's nothing preventing me from making one which, you know, does some super simple dynamics perhaps, and just, you know, some AABB overlaps or something, maybe some BBH sort of thing. And I could have sort of like my own physics library or collision detection library if I were to build some sort of app that needs just some super basic things. That's my biggest gripe with Odin. Many of the physics libraries are C++, and you need some intermediate C bindings to bind to Odin. Yeah, Bullet. Well, Matt says that Bullet is included in Odin. I don't know about that. Maybe it is. But as far as I know, Bullet has a like C API already. Isn't that the case? Oh, it's only box 2D. Yeah, I'm pretty sure Bullet has a C API though. Yeah, let's just let the mother vehicle do its thing here for a while. That's the whole point of this. Just keep it running in the background, and we can go back to it in a second. Right, even the website is these days are called PyBullet for the Bullet engine, and if we go ahead and have a look here at the website, I'm pretty sure this guy actually has a C API of some description. But now I don't remember where it is. Is it maybe actually in these, or is it perhaps generated somehow? Pretty sure there's a manual somewhere, but yeah. They 100% focus on the marketing, robotics, and machine learning. Yes, I find that a little sad, because Bullet is seriously like, if you just want basic, dynamics and collision detection, Bullet is actually awesome. Just because it's so simple. Like the Bullet backend that I use the Bullet version that I use for my backend is 2.8.6. It's kind of confusingly named like Bullet 3/286. So this is not actually even the most recent one, but here's the manual for that. And I'm pretty sure there's like a C interf, no, C API, no. Okay, can't find it. Interface. Maybe I was wrong. Maybe it doesn't actually have one. All right, let's see how's the mother vehicle doing. Still going at it. Yeah, I'm gonna let this run overnight and see what is happening when it comes back. WR start. No, thank you. Are you using the shader to do edge highlights, or is that just baked into the texture? It's baked. It's baked. Yeah. It's baked in Blender. I am using a shader in Blender to generate it, but it is baked. Yeah, you can abuse a bevel operation in a Blender shader to generate those edge highlights for you. You can use multiple spheres to make a body approximation. Yes, yes you can. I use that to to calculate distance between vehicles, for example, and the mother vehicle is just like a bunch of spheres along the vehicle, I think like 3 or 4. And then it just calculates the distance between the spheres and whatever you want to calculate, and then gets the closest one. It's kind of approximate, but it's typically good enough. Or basically always good enough. Right. Yeah, let me know if you want me to show the Blender setup for that. I realize it might not be something you're interested in. If you are interested in doing it at runtime, but I guess you could probably do the same thing at runtime if you have some sort of a bevel operation in your shader. Then you could maybe do it at runtime. It's like a bevel and a dot product, I think, and then because if you're beveling an edge and then you're comparing, or you're beveling like a surface, right? Yeah, that probably wouldn't really be something that you would have in a runtime shader. At least I don't know exactly how that would work. Maybe it would work. But in Blender, the way it works is that you're beveling the whole object, right? And the bevel gets applied at the edges. And then you compare it to the unbeveled geometry. And because it is applied at the edges, that is where you get the difference, and then the difference becomes essentially like the highlight. Excuse me, still have this cough plaguing me. All right, I'll show you. Let's park the car here so that we don't stand in the way of the mother vehicle. Let it run its circuit here. So what are we looking at, or what should we look at? Let's do the display quad maybe. Oh no, that was actually just that. Okay, that's not very helpful. We can do the gatehouse maybe. We can do the gatehouse maybe. Right, so let's look at something that has a lot of angles, like these vents here. So I'll need to select that. So we actually have an edge highlight material here. This only currently works if you are in the viewport shading, or the rendered viewport shading. I mean, it doesn't work here in the what is this called? Is this like yeah, material preview? Annoyingly, you have to be in the rendered shading for that to work. But this way you get the highlights like this. We have the material here. You can see here's the bevel node that I spoke about, and you have the dot product. So basically these two nodes here are doing the magic. Then you just need the normal of the face to compare it against, and that then lets you tweak this however you want. Like you can make the radius really large, and you can play around with the samples, so you can make it super tight if you want that. I kind of typically go by eye, and that means that my edge highlights are sort of they're kind of depending on the size of the object generally. You can see here that this rock has larger edge highlights than the car, for example, and that just typically has to do with like, okay, how do the edge highlights look good on this particular object? But you can see that basically everything has edge highlights. Everything that is a mesh, that is, so the grass doesn't have it. Things like that. But yeah, this is then baked into texture. So we have the edge highlights for. Alright, that's the details. With the edge highlights for the building here. So it looks like this, and basically you're baking, and you need to use cycles for this, by the way. It doesn't work with Eevee. I think actually this bevel node doesn't work with Eevee. You need to use cycles for that. It's also kind of annoying. But on the other hand, you need to do all the baking with cycles anyway. I think like this bake section here goes away if you use. Yeah, there's no bake there at all. So I guess it's a moot point in that sense. Anyway, you have this. You bake to this texture, and then what I do, and this might be different than based on how you actually render if you're using PBR or something. I don't use PBR, so that makes my setup a little strange maybe. You then have this master material here, which you bake out to a diffuse texture, which has the edge highlights. Here we go. There's the edge highlights. So we can toggle it on and off. We should be able to toggle it on and off. That's strange. Right, so that's a painted stuff. Edge highlights is right there. Oh, it's, yeah, okay, I was toggling the wrong thing. Yeah, so here you can see we can toggle the edge highlights on and off. And in my opinion, just drag this off to the side. In my opinion, this just looks kind of bland compared to this. It just gives it a little bit more oomph when you add the edge highlights there. Well, yeah, that's it basically. And then it's just rendered like this. Of course we have like light mapping and stuff here applied on top of this still in the engine, so it does look a little different here, but basically the same. I thought it was just based on the angle of the vertices. Well, it is technically exactly that, right? The dot product is the angle, basically, because we're comparing it against the normal. It's just that this bevel node in Blender, it sort of like generates more geometry conceptually along the edges, makes the edges more smooth, and as a result of that, the angle, the normal angle changes. Hey, look at that. Here we have another. Let's pause this actually. This is another issue, and I have some plans for how to solve this as well. But we'll see what happens. Anyone care to guess why this has happened? Why has the cable gone through that and is now just sort of hanging there? Looks kind of fun, I guess. And the reason that is happening is the cable is made out of segments. And now we are looking at a situation where two segments have somehow gotten to the other side of this door here. You can see they don't actually line up because the physics are not interpolated, while the visuals are. And also we're now looking at the server side, and this is the client side. So client might actually be kind of slightly more aligned, except that that cable doesn't exist on the physics client side. Is the cable multiple spheres connected and the plane is stuck in between them? Yeah, except they're not spheres. They're just these boxes. But yes, otherwise you are quite correct. So we might be able to mess with it to get it unstuck. But that's something that we should probably have a look at some point. See, if I create like a power cell there and then unpause the game, sometimes you can you can force it to sort of unbug itself. It's determined to be stuck there for now. Alright, well it doesn't really matter for our physics test. But yeah, it's another one of these issues with the crane. The crane tends to be the most, I want to say, impressive part of this game currently, physics-wise. Most people, when they see the crane, when I show this game to people for the first time, they're like, "Ooh, I like the cable." But it's also the piece of the game that just tends to have the most physics bugs. Just getting rid of these guys here. Boom. I could of course just destroy the objects. Yeah, I actually think, realistically, I think that the moment you enable the magnet for something such as that garage door, the cable should stop colliding with the garage door, or at least not necessarily all of it, but maybe parts of it. I'm not sure. I have to kind of think about that a little bit. I'm thinking that might be a good idea. Well, then we have to... Yeah, I'm not sure. We can sort of mess with the physical representation of the cable as much as we want, because as you can see, like the visuals don't really matter. Like they're built, they're generated from the shapes. We essentially run or generate, I should say. Generate a Bezier curve, like a curved path along these positions, and then out of that we mesh, or update the mesh for the cable. Why does the cable need to collide at all? It doesn't need to collide. It works as a crane. It works perfectly fine without it colliding at all. It does, however, mean that if you are... We can create another mother vehicle here and demonstrate this. Let that one run along its merry way. So, you know, if we want to do something fun like this, where you just start spooling the cable onto the back of the vehicle, or the floor, I mean the ground, or whatever. If you want to do something like this, just, you know, to show your friends that you have the hottest new game in town called Traction Point. And oh, yeah, maybe it's best they don't do that. But still, if you want to do something like this, right, and the cable doesn't intersect with anything, that would mean that the cable would sort of go from the tip of the crane, just like hang in like a long sort of loop like this, and then back up to the cable, or the magnet. Sorry. So I guess there's some coolness factor in having the cable actually do things like this. But yeah, it doesn't need to collide with anything to sort of work as a crane. You're quite correct in that sense. But I think this looks fun. It just looks fun. Yeah, I don't know. It's not the end of the world. We'll figure it out. Or then we don't, and leave it as it is. Yeah. One thing that we could do if we just really wanted to over-engineer this is to somehow detect if there's something sort of in between those segments, and then take some action based on that, right? That's also something we could do. But yeah, I don't know how much it makes sense to actually fiddle with these things. The most important thing, and the thing that we are currently testing for, is that the game shouldn't crash. And the PhysX 5 solver, the new temporal solver, is proving to be really, really good in that case, or in that sense. Where's the other mother vehicle now? Where are you? There it comes. It would have been interesting to see what actually happened that got it. I mean, you can get it kind of easily stuck like that. It's not really a big mystery, but it would have been kind of interesting to see what happened. Oh, the scout is in the way now. Yeah, it's a little, needs to try to drive around it. It kind of manages to do that. I just drive like straight into, collide with the mother vehicle. Both vehicles driving at 55, so it'll be a collision of 100 kilometers per hour. And we'll see if that untangles it. Of course, the other mother vehicle will try to evade me, but I won't. Alright, let's go. Let's go, come on. Come on. Yeah, no problem. You'll be on your way. Hey, I mean, I kind of like this cable just sort of flowing all over the place, right? Giant Rabbit Games says, hello, first time here. I'm impressed by your engine. It's inspiring me to build one in C. I'm glad. That is like the thing that makes me the most happy, in that people are inspired by my stuff to build something cool. Best of luck with your own stuff. Do you have wear and tear textures yet? Yeah, I sort of do. I've been going kind of back and forth on the wear and tear and how much of it there should actually be. And I'm kind of settling on not that much. Alright, so obviously this art style is very sort of simple, consisting mostly of like super desaturated colors and single colored. Actually, let's let this run. I'm just gonna stop here and let the other vehicle just go about their way. Like if you take this guy for example, just flip it on its head, we can see some you know, dirt or rust or whatever you want to call this stuff here. There's sort of like I've just painted a layer of you know, crap onto this thing, mostly because not really like there's no big kind of artistic or visual sort of idea behind that. It's mostly just that it kind of looked strange without it. Same thing here with this wall here, for example. There's a little bit of just like crap painted on this guy, and this one as well, and most things, not all the things, but most of the environments have some dirt and crap. Notably not the cliffs, but I'm not super excited with these cliffs. I'm kind of thinking after the demo I might have to reconsider my art style for the cliffs. I haven't really decided. They're kind of nice in the sense that they're kind of easy and fast to model, but I'm not super sure about the look there. But yeah, again, if we just quickly take a look at the gatehouse. Here we have the gatehouse. Here we have something that's conceptually sort of being flowing out of this vent here, right? So if we not that, I'm gonna get this. We can see here at some point we have painted details. So this guy. So if we toggle that thing on and off, you can sort of see without any sort of painted details, this thing just looks super boring in a way. You can just toggle it on and off and you can see the difference there. It's very subtle, and like I said, it's not really that like I decided that it needs a little something like that. It's more like without it looks bad, and that's my solution to it. So, but not everything has it. Mostly like the really big ones. Oh, we've gotten stuck. We've gotten stuck, haven't we? Right. This is actually this is actually a physics issue now. A PhysX 5 issue. And this is one of those things that I had in my fork of PhysX 4 is something called torque vectoring, which basically means that it intelligently splits up the torque between the different wheels. And my version of it that's used for the mother vehicle is such that the wheel with the most compressed suspension gets the most torque. And so you can see there like one wheel spinning in the air. That's because the differential that comes with PhysX, with PhysX for the N-wheeled vehicles is kind of basic. So I bet with PhysX 4, with my fork of PhysX 4, it would actually have gotten off that rock faster, but it did get so. So that's kind of nice, I guess. Hi, I'm Paco. Well, hello Paco. Welcome. Found the channel a few weeks ago, incredibly impressive. I love the lighting, the physics is on point, just wow. I'm making a little engine myself in C++. Well, best of luck with that. And thank you for your kind words. The physics aren't really on point though yet. That's why I'm working on them. But thank you. I'm glad it is inspiring. I guess the AI should work harder to avoid things it can't safely drive on. Yeah, it should. It should. And it's done a few things today that I kind of don't really know why it didn't avoid them better. Actually, we're coming up on one of those cases here now. We can have a look at how it handles this turn here. Let's detach the camera for a bit, and we can see. Let's pause the game here and see what we have. So nav mesh. This is the nav mesh that the mother vehicle uses. So previously it wanted to drive into this cliff here, and it should have avoided that as a hazard because this nav mesh is cut out for this area here. Let's clear the log and let it continue its thing. See what happens. Oh, and we are actually already, we are in its way. Yeah, you can see that there's something strange with, it's almost as if the hazard prediction is off. You can see these white spheres there. They should turn red when they are off the nav mesh. That's the hazard prediction. Yeah, you can see that clearly it doesn't actually. Yeah, I guess it might be because they're only used in some specific cases. I think they're only used like if it's cornering enough, just to handle cases like this where it would like otherwise sort of unnecessarily try to avoid things. So I think that might be the reason. But still, I think it's kind of missing some of the hazards here, driving kind of badly in some cases. What rendering API do you use? Well, this is D3D11 as can be seen there in the corner, but I do support a few. D3D11 is kind of the one that I keep coming back to because it tends to be kind of easy to use. Right, yeah, that should definitely have have triggered some. Or maybe it shouldn't. I need to look at my my logic. I think I toned down the hazard detection a little bit because it was trying, like there, for example, you could see that a lot of those points would have been sort of off this nav mesh here, and it just like it panicked in cases where it really wouldn't have needed to. So I think that was the reason. But yeah, you're quite right, quite correct in the sense that it should try to avoid some of those cases. I'm not exactly sure what happened here. It is possible, and I think I know what happened now, seeing that this guy is here. And we are stuck ourselves. I think what happened is probably that this guy was standing somewhere here in this junction, and as you can see, this thing actually cuts out a piece of the nav mesh, and in addition to that, it is raycast against, so it will figure out that okay, there's like a dynamic object in front of me, and then it tried to avoid this scout vehicle at the same time that it tried to take that corner, and then it sort of was led into that rock. I think that's probably what happened. But yeah, it needs some more verification and testing for sure. Well, but the music ran out of music. Alright, but it looks pretty good so far. No crashes. We haven't had a single crash, in fact, with PhysX 5. That's really nice to see. That bodes well for the stability related to the crane there. I wasn't sure to go with DX and went with OpenGL 4.5 because I was worrying about compatibility with Linux. I'm targeting Windows only. I'm concentrating on Windows, let's just say. I do have a metal renderer and a web GPU renderer, which I guess technically should work on Mac as well. Though I haven't tested that actually. And I'm pretty sure the metal renderer would need a little bit of work to run this game currently, but the engine does run on Mac, with the caveat that I would probably have to spend a few days fixing up the rendering because I'm trying to concentrate on the game now rather than just building tech all the time. So yeah, I'm targeting Windows for this demo, and then we'll see what happens with the final game. The game actually does run on Steam Deck, something that I just tested for fun over the holidays. Just run it. I didn't do anything except I set the Proton compatibility layer to you know, the latest Proton, whatever it was, and started it, and it ran. It wasn't able to load a game though, so something with that wasn't working, but the game was completely functioning. That was fun to see. I would avoid Mac sincerely. Yeah, I understand what you're saying. Mac is pretty good though, in the sense that well, first of all, I have a Mac. I have several actually. And if you are targeting like one non-Microsoft platform, like if you're building on, if you're building the game primarily on Windows, then my suggestion is that you also target one other non-Microsoft platform. Because if you're only targeting Windows, then you're probably doing all kinds of very Windows specific things, and you have no idea how easy it is to get your code base to run or even build on another platform, right? But if you're targeting one other non-Microsoft platform, then there's a pretty good chance that you can run it on several non-Microsoft platforms. And so that was kind of my reason to actually run it on Mac as well. I will say that Metal is a super nice API. It's probably like my favorite API, if we're being completely honest here, out of all of the current ones. What I don't like about the Mac is that the platform is just getting more and more closed all the time. Hey Cacti Crown, welcome back. Yeah, so it's a little bit of a, if you want to actually like launch a game on Mac, right? Then you need to do more work than you need to do on Windows or Linux, I guess. I'm not a very experienced Linux user, but on Mac you need to do kind of like signing and all that crap. I don't particularly enjoy, but the Metal API is really nice. I will say that much. And it needs to be said that WebGPU is also kind of nice. I really don't like the shading language though. Or I mean, I like it about as much as I like Metal shading language. I don't like the Metal shading language either, but I can kind of expect Metal to have its own shader language, but I don't really like the fact that WebGPU has its own. How much work that has been put into Proton? Linux is in a good shape now. Yes, it is. It is surprisingly capable. I will say that. How much would traction point cost? I have no idea. That has been asked before, and I've always said that I don't exactly know. And of course, it also depends on the market that you're asking for. But if you're asking about euros, then my completely sort of pull out of a hat answer is going to be somewhere between 15 and 30 euros. I don't know. I have no idea. That answer might already be out of date as of this second, but something like that maybe. That's kind of what I'm thinking. And Paco says, I'll try to keep it OS independent as much as possible. That is good. That is good. do remember to run it on different OSs though. That is really the only way to know how OS independent it is to actually run it on Windows and Mac and Linux. Or some combination of those. If you don't like Mac, then maybe run it on the other two. Oh no, we're pulling our magnet behind us. Oh no. It's gonna get shot into space. I feel like niche technical games attraction points safely can raise their prices above the average since they tend to have a deeply interested audience. I hope I have a deeply interested audience. I don't want to necessarily ask more than people are expecting just because of that though. But we'll see. I haven't quite figured out how much game in the traditional sense there will be in this game. Like obviously I would like there to be like a 20-hour campaign and multiplayer and sandbox modes and everything. Obviously I would like there to be that, and it would be like an awesome value proposition for anyone interested. But the fact is that I just don't know how much I can produce and in what form, and I also don't know sort of if everything will be released in one package or over time. I would like to sort of exploit the fact that I have all of these tools, including the full level editor and everything, and I can release those if I want to, which would mean some sort of mod support or maybe even parts of the code being open. Whether or not that actually leads to sort of more value for money, I guess that's up to each individual player to decide. But yeah, in the end, I just want to make a game that people want to play. The advice here is target higher than you might, or low enough to be an impulse purchase. And which one you pick depends on the game. Yeah, I guess that's probably true for a lot of games. Mod support would be nice. Yes, it would. Yeah, I should probably look into things like Steam Works and stuff like that at some point, but there's just like so much to do. Feels like BeamNG or Gmod in terms of what audience it might find. Yeah, maybe. I mean, BeamNG has a lot of really dedicated car people. I mean, it has all kinds of fans, I'm sure, but it has people that are really like, yeah, this is a really good simulation of cars. And I will say right now that this is not a simulation of anything. Anything realistic, at least. My sort of go-to inspiration for this game, more than anything else, is actually Halo. Like Halo is not a simulation, but Halo has a super awesome sort of sandbox that the game is based on, and in that sandbox you can do things based on your intuition a lot of the time, especially when it comes to physics. And so that's something that I think I would like to inspire to sort of target with this game as well. That doesn't mean that necessarily the same people who like BeamNG for its kind of realistic simulation are going to like this, but maybe they will. I don't know. There's also like a whole narrative side to this game that BeamNG doesn't have, as far as I know. Halo Reach Forge, yeah. What's the vehicle called? Mother. Ah. I wonder if I can't remember how much I've actually revealed about that thing. I think you might just have to play and find out. But I guess I guess I've revealed certain things about that, so I can do the same here as well. So in the game, in the campaign, you have a bunch of vehicles. We have the Scout, for example, and we have the mother vehicle, and we have some other vehicles that can be considered sort of secondary. Things like the gripper that you find in this level, for example. And then you have a bunch of characters, like actual people. And you may have seen some of those in some of my streams and videos when we've actually played the campaign. This is not now. We're not in campaign mode currently, so there are no missions or anything going on. And the mother is actually both a vehicle and a character. If that makes sense. And if it doesn't make sense, then you're just gonna have to play the game to find out what that means. What's the networking and data model like for the engine or game? I feel like I'd have gone with ECS if I was making this type of game. Yeah, there was actually already a question about ECS earlier in the stream. And I said that I don't use ECS as sort of the representation for the game objects. I've used ECS with this engine on stream, or not actually on stream, but on video in the past. There's a video about basically sticking an ECS into this and running certain parts of the simulation through that. There's nothing from preventing you from using ECS for a certain part of the engine if you really want to. But the entity model or game object model or whatever you want to call it in the Basis engine is not ECS based. No. And of course the reason for that, if you've seen my recent video, I've actually been using this engine for a long time. Back when I started this, no one was talking about ECS. And I had no idea what that meant. And I thought I was very clever when I came up with the game object model that I currently have, which is a little bit like Unity, but not, or I mean the monobehavior Unity game object model thing that most people are probably familiar with. We're bouncing around. But it's not quite Unity. And yeah, that's the reason why I don't use ECS. If you want to use ECS for your game object model, then by all means, do it. I don't think, honestly, I really would benefit from ECS in this game. Like I don't. Maybe you know more than me. But I've used the ECS in some games that I worked on. And some of the companies that I've worked on or are working on still, or at, shall we say, use ECS. And at least the reason why we have gone with ECS is the fact that it makes it very sort of like, if you have a lot of game objects, that's one reason why you would want to have an ECS, because it tends to make updates more cache friendly. If you have a lot of objects just updating all the time, that can make it more cache friendly. It can also make it more multi-thread, multi-core friendly if you have a really a lot of heavy updates going on. I don't really have that. Most of the game objects in Traction Point they don't actually necessarily even have an update function at all, so there's nothing gets updated. And like I've said in the past, I don't use like virtual update functions or anything like that, so my updates tend to be kind of cheap anyway, and 90% of the time goes to rendering, which tends to be like a separate system anyway. ECS is like a religion today. It is, yeah. Yeah, it is. It's really strange. Like I mentioned in the past, that a lot of the things that Jonathan Blow says kind of tends to make me roll my eyes. But he had a very good point about the ECSs and the fact that everyone is making an ECS these days. I don't exactly remember what he said. I'm sort of paraphrasing here, but the gist of it was that, like, if you're worried that you know your engine won't be performant enough because you don't have an ECS, then you better have a game that actually has an update that is worthy of that worry, right? Like, most of the time it's going to go to rendering anyway. Like, the game objects, the update of the game objects is typically just like a fraction of where your actual frame time goes. So unless you have actually sort of profiled and made sure that, oh, okay, I'm actually taking too long here with the way that I'm updating this simulation or this world or whatever, then like the performance argument for ECS isn't really valid. If you want to work with ECS and you just feel like, oh, this is actually how I want to write my, you know, gameplay code or whatever, then sure, then that is a valid thing. Some people really like writing ECS code. Anyway, this got kind of rambly. What was the other question? What's the networking and data model like? How should I answer this? The networking is, well, it's client server based. It's sort of like a controlled chaos model is what I like to describe it as. Currently we are running the client and the server on the same thread, and we are doing that mostly because that allows us to actually visualize what this guy is doing here, the other mother vehicle that we are actually trying to get to crash the game here, which so far hasn't happened, so yay us. But if you run the client and the server on the same thread, you get to see what the AI is doing here in the form of this AI inspector and these trails that it renders and all of that. But you can also see the client and the PhysX shapes. So you can see the yellow ones are the server ones, the green ones are the client ones, In some of these cases, you can see just one. Like you can see here, for example, there's a green one. I think that's just because it's sitting absolutely on top of the other one. So if we're toggling the other one off, yeah, if we don't actually draw both of them, the color is determined by PhysX. So we have all kinds of colors here determining various things. But if you have both of them running, then all the client ones become green, all the server ones become yellow. As you can see that there's actually like a server one underneath this. It just like happens to sit exactly on top of the other one. Here we have, for example, the client. If you drive around this, you can see that some things are only simulated on the client. Some things are only simulated on the server. This antenna here is only simulated on the client. This crane here is only simulated on the server. So you can sort of decide which parts you want simulated on what. And then it kind of corrects itself over time. That is kind of how the network model works. So it's not deterministic, not by a long shot. We simulate the physics both on the client and the server. So we're actually now running just like as a point to what we talked about earlier about not needing an ECS. I'm actually running two worlds now, two simulation worlds with, you know, full physics simulations and everything. I'm running two of them now on the same thread. And that's not something that I normally do. Like in the shipped game, the server runs on another thread just to, you know, offload some of the work there. But I'm now running two worlds on the same thread, and like the game doesn't break a sweat. It just works perfectly fine. So like I don't know what I would do with the ECS here in this case. And yeah, so the network model is such that by default the server owns everything, and it periodically sends things over to the client, and you can affect, you know, what is reliable, what is unreliable, and certain things are immediately sent over as soon as they are out of date. Other things are sent according to a priority system, and it tries to kind of balance the thing. If you're wondering why this sort of flickers this physics simulation, by the way, that has to do with the fact that the physics aren't interpolated, only the visuals are. And we're actually running now on a 75 Hz monitor, so we're running at VSync 75 Hz. The physics simulation is running at a locked 60. So that would be why it is sort of jittering like that. Boom. For me, the main argument for ECS was to have really easy networking, because the network layer can just be generic over the ECS itself. Yes, if you have a reason like that, then using an ECS might be perfectly valid. Absolutely. For me, using this networking system like this, even though this engine wasn't specifically made for this game, one might argue that it kind of was, but because if you watch my 15-year game engine video, you would see that even the first game was actually a vehicle game, like a tank game. And the reason for going with a network model like this was that networked physics, two cars sort of messing around with the same dynamic objects, that tends to be really hairy if you want to have like a deterministic, like a Quake model and a network layer, right? So this system handles that case quite well, because the client is essentially just simulating everything, and the server is also simulating everything, and then it is gradually correcting things over time, and certain things might only be executed on the server. You know, if you have like a PvP game, then you would like, it would only do the death logic, or the damage logic on the server, and so on. So I'm not sure how that ties into the whole idea of running the networking layer over ECS, but that might be a perfectly valid way to do it. So if you have a sort of an idea of wanting to do it that way because it solves some solution you're having, then sure, then you should absolutely do that. Yeah, I think we're probably sending more data now than we would normally do, because this is like a development build. We can see some of the network stats here. So 20 kilobytes incoming data, and we're sending 16 kilobytes per second. So it's not like super optimal. I don't do any bit packing or anything like that. I just do like delta compression. I do some compression of like quaternions and things like that, but I don't do any bit packing. So floating points are quite simply just serialized and sent over. But you can typically, let's see if we can get something going here. Some dynamic objects. Oh, I'm sorry, I'm in your way. I didn't realize I was standing right where it was trying to drive. Right, so now those things have fallen asleep. And we can see the incoming data is more or less stable. Now if we go and mess with these guys and like have them actually send their data, you can see that we get like a little bit of a spike there in the data sent. And it just has to do with well, there's not really that much going on right now here, but if we had lots and lots of dynamic objects, then they would be sent in sort of like priority order, so it would try to make sure that all the objects get synchronized eventually. And here, now that we are doing this, we're running this in single player mode, we're still running a client and server. The network connection is completely faked. It's just a buffer, basically. We just memcopy to and from a buffer, but we're still running the rest of the networking layer here. So you can essentially run this same code in multiplayer mode. It should basically work. Have you tried Bullet PhysX library? Yes, I have a Bullet backend for this engine as well. So I think I probably built it earlier today, most recently. So here we have PhysX, you have PhysX 5, which is the topic for today. Here we have Bullet. So it's its own PhysX backend. I can't run this game with Bullet because it's dependent on the PhysX vehicle SDK. But if you just want to do basic rigid body collision detection and simulation, you can just do that. You just load the Bullet plugin, and then it will use Bullet to handle that. So basic shapes, basic rigid bodies, triggers, all of that works fine using Bullet as well. All right, people. I I keep mentioning this, but we haven't crashed a single time. That cable got kind of entangled into the thing, though. It is almost coming loose, though. Looks to me. So I think it's gonna come loose sooner or later. But PhysX 5 has been so far actually really good. That's nice. And that bodes well for the demo. So yeah, even though we had to debug the AI a little bit today, and there might be one or two bugs there that I wasn't aware of, or it might not be bugs actually, it might just be like some tuning needed. Even though we had to do all of that, it is really nice seeing that this guy has now driven around with this problematic piece of geometry attached to the crane for like a couple of hours already, right? How does it compare to PhysX? I guess it kind of depends on the context. For me, specifically for me, it lacks the vehicle SDK that PhysX has. And as we've actually talked previously today in the stream, PhysX 5 actually has 2 vehicle SDKs, and I have support for the older one and some bare bones support for the newer one. But this is all using the older one. Bullet also has vehicles, specifically raycast vehicles. They're much more basic than what PhysX has. So that is basically why I use PhysX. Steamworks was surprisingly easy to integrate, and it's cool seeing it take shape. Oh, that sounds promising. What are you integrating Steamworks into? Multiplayer gaming Bevy, Neo4j for persistence. Cool. So you have a like a product that's out and with mod support then, or is it just like in development? But yeah, that's cool. I need to look at the Steamworks stuff one of these days. But right now I should really get this demo out for you guys. And these physics bugs don't make that any easier. But luckily we have some progress now with PhysX 5. Okay. I think I have a I have a kid who's going to be asking for food soon, so I'm gonna have to think about maybe wrapping this up soon. But this was fun. I need to get back into the habit of streaming after not really doing it for a while. I think I will do a stream at some point where I model a bunch of props, dynamic props. So we still don't have like a whole bunch of dynamic things to play around with in the level. We have the power cell, which is of course needed for the actual mission to complete, and we have a few of those. We have this dynamic crate, which was modeled. I think I modeled this on stream, but can't remember. Like ages ago, and it never got really sort of past this. I don't know what that even is, like concept phase. Didn't get textures or anything like that. And then we have some like you can spawn like debug boxes, right? Like one of these guys, for example, or something like that. We don't really have a whole lot of dynamic objects to play around with here. So I was thinking I would have a stream. I would have a list of objects that I would have sort of thought about in advance that I want to actually have as props. They don't even necessarily need to be dynamic, but most of them probably will. And then we're gonna just like model all of them, and I'm gonna do like a 20-minute time limit per object or something. I don't exactly know. It's just an example, but something like that. And then we're gonna model like 10 or 20 of them or something and put them into the game all in one stream. That could be kind of fun. Notice one thing, you seem to be very quiet. I was maybe mumbling a little bit. That might be the reason for it. But yeah, by all means, let me know. Let me know now and in the future if my audio or video, for that matter, isn't up to snuff. Like we started this stream in sort of a rough state until Matt notified me that hey, shit's broken, yo. Clarity-wise, it's perfect, but volume amplitude-wise, not really. Okay. I'm in the yellow here in OBS, so I don't think I want to go necessarily much higher than that, or it's gonna start clipping. But yeah, I'm also sort of losing my voice here after talking for what's it been? Oh, over 4 hours. So that might be it as well. But let's hope it's a temporary thing, one way or another. Maybe have some logs scattered around the place. We actually have some logs. I don't know if you've noticed. I need to remember where I put them. I actually have logs here. I'm gonna go now. Have a great day. You too. Let's catch up later. Yeah, look at that. Here's a log. Here's a log. The log is not actually dynamic though, but we do have logs. That's one thing I do have. Yeah. Most people and videos tend to slam the volume into a limiter set at like -1 dB. Yeah. Yeah, what you have to understand with me is that I don't know anything about making videos, like seriously. I've been doing this YouTube thing since like, what is it, 2018 now, and I'm still just as noob as I was. I think the only thing that I've actually gotten better at is the actual talking, right? Like, I don't sound like someone just hit me and took my lunch. When you look at my older videos, I'm like, hey guys, welcome to the... It just sounds like someone's been really nasty to me. And I think that that's the only thing I've gotten better at over time, is like maybe talk a bit more purposefully. Bye bye, Williamus. Thanks for today. Have you ever tried to build my own physics engine? No, I haven't. No, I don't think I have quite the stomach for that. In fact, I don't want to do that. Like, there are certain things that I just don't want to do. I find it kind of interesting to build all kinds of tools and frameworks and systems, and arguably I shouldn't build some of them. Things like the audio engine, which is actually powered by SoLoud, so it's not completely made from scratch, but still, like, I like building that. I don't feel like I'm very good at it, but I like building it, and I want to build it and improve it. But I don't want to actually build a physics engine. I don't think. If I build something, it would be like a super simple collision detection library or something like that. But hey, you should do what I do, or I don't know if you should do what I do, but my suggestion is this, and it is what I have done. Let's shut the game down. It hasn't crashed, so I'm kind of happy with that. I'm probably gonna let it run overnight, but we'll see. So what I've done is this, and I seriously need to go soon, but let's end today's stream with this. So rigid bodies, right? They're kind of cool. This is how my rigid body system looks like, and and yes, it is using virtual functions. If you don't want that, you don't necessarily need to use virtual functions. You can still have an interface, and then you, through some compile time logic, you actually fill in those blanks that you need to actually simulate, you know, a rigid body. I've done it through virtual functions. I use runtime loading of the actual sort of backend. So that's why it's virtual. But if you don't want that, you don't have to do that. But basically the idea is the same. I have a rigid body dynamic, and I have a rigid body static, which is found here. And I have a physics material, which is found here. And I have a what do we want to shape? And shape is found here. And you can see that, like, these are just sort of interfaces essentially. They're not really interfaces. This one has a shape description here, but you get the idea. And then, if you want to try out, start with like a pre-made physics engine just to, you know, get the ball rolling. You can have different backends, and like I said, I actually select which backend I want to use at runtime, but you can do it at compile time if you want. And so I had a rigid body bullet. Now that's a static. If we want to look at the dynamic one, we have it here. So rigid body dynamic bullet just implements a rigid body, and it uses a collision shape as it's a root shape. It can have more than one. It has a BT rigid body, which is like the bullet rigid body thing. And then We have the PhysX, this is specifically the PhysX 4 version, which has a PX rigid dynamic. And then of course I have the PhysX 5 one, which we looked at today. It looks basically exactly the same, this part of the API. And several things in the Basis engine work like this. You have an API like this that looks some way that you actually want to sort of use on a day-to-day basis, and then you implement it somehow, and that can be compile time or that can be runtime. It's up to you how you want to do it. The nice thing about this is that you can then, if you want to go like, okay, I want to build my own PhysX engine, then you just build a backend for this. And you don't need to like throw away what you already have. You can have more than one backend, and you don't need to change any of your game code or even your engine code. But if you want to, try your hand at building a PhysX engine, then you can just build a backend and plug it in, and compare it to Bullet or whatever. So that's one way to do it if you want to sort of gradually build your own stuff, but still sort of keep some other options at hand. And that's also how I do networking, and that's how I do rendering and everything through like a similar sort of system. Alrighty then. This was fun. I think I'm gonna end the stream here. I'm gonna go take care of some family members. If you would like to join the Discord, I am going to post a link in the description, or in the chat rather. Where some of these discussions that we've had today have sort of started over there. Let's see if I can find the correct one here. Oh no. I keep posting like expired ones. I don't know where I sort of originally got some of these, but they're expired. I need to figure this out. I need to update them properly. Let's see. And now I realize here that I posted some of these expired ones in my video descriptions as well. That's stupid. So the one we want is this one, right? Yeah. There we go. That's the one. That's the one you can actually use. That's the one that actually works. And I realized that no one was asking for it, but I gave it to you anyway. So there. Let's update some of these video descriptions while we're at it. And if you don't want to join Discord, then at the very least you should subscribe to the channel so that I have some way of telling you when the demo is ready. Provided you want to play the demo, of course. Maybe you don't. In which case, do whatever you want. It's up to you. Yeah, I think these are now updated properly. Yep. Looks good. Anyway, thanks for hanging out today, everyone. I'll try to stream a bit more often, and if you're interested in seeing me model a bunch of various things, to place into the level so that we can actually mess around with more physics, then be on the lookout for some sort of prop modeling stream, because I think that is coming up pretty soon. But other than that, have a good evening, everyone. Approximately when, maybe. I don't exactly know. I'm gonna have to figure that out. Probably within like a week or two. And maybe roughly the same time. This is sort of like afternoon in Finland, so whatever that makes it in your time zone. But I will most likely post on the Discord when I plan to do that. Give you a couple of days notice before that happens, if you're interested. Alright folks, have a good one, see you later.